Okay. Okay, so lots to cover, and we'll stop at 7 o'clock or maybe 6:30, so that we can do the presentation. So these are the exercise that I assigned to you guys for the past 2 weeks, past week. So the first one, who wants to volunteer to solve the first problem? You should have already seen them. Yes, please tell me. Summarize the questions and then give the solution.
Post date time are considered as a primary key in this table. So as you know, the primary key cannot be now. I think that our will see that time is now.
Yes,
Yes,
yes. Did everybody hear me? Okay, so this lesson and with the algebra that shows in here, relational algebra, it shows that these three together is the primary key, one and only primary keys. What is the name for these type of primary keys? What do we call it? Yes, combo, composite, yes, composite keys or combinations or combo keys, okay? So this is the primary keys. And the first, one of the rules of the primary keys is that it cannot have no value, okay? But the second thing, let's see if there's any other. So
Row 4 and 5.
yes, I understand. Give me 1 second. So okay, there's a duplicate here. All right, that's definitely an error here. So they cannot show up more than one time if it's a primary key, right? That we know of. You cannot have duplicate keys. But in this instance, actually, this no value actually doesn't make this key valid. Because together it's not null. That's it. If this time here by itself is a primary key, you cannot have null. Understand? But I get where you're coming from, but this actual composite key here, together are three, with one part of it being null, is actually not incorrect. You got it? Because three together is now like null. Understand? Right. So it's a combination puzzle. But the identity here that shows up twice, that is the main problem of this table. So this is definitely an error. Okay? All right. Number two. Does anybody want to? What about number two? Who wants to volunteer and solve this? Exercise 2.
It has binary key validation.
Yes.
The company ID.
Sorry. What is the validation here?
The company ID.
Why are they wrong? Why is it validation? You want to? I want not only give me like your solution. You feel free to try. That's fine, no problem. Just tell me what is your thinking behind it. What was wrong with it? Anybody else want to try? Over here.
The services table is
Use service, okay.
yeah. So in the column, the company ID uses C1, which is not one of the operating services.
Okay. That's definitely one error, correct. Anything else? C1, S2. These two doesn't exist here. This is the table that refers to this one, right? So if there is a foreign keys, these are called foreign keys if it's referring to primary key here. They need to exist here. Yes, that's one of them. What else? Yes.
One of the has a law in that one is in
Is that? But it's a composite.
But I mean, I thought it has like a bar on the table that would be.
Where?
Like you serve like it, if it doesn't have like a star like for the column it. It has to be,
A star?
yeah.
What do you mean, here?
Yeah, like right after the, where is the date, yeah.
No, not by default, no. I don't think that's the problem.
I mean, but also, I think. A1 S3 doesn't exist in the offered services table.
Wait, A1, this one?
Or in the use
Sorry.
services, A1 S3,
A1, S3.
that should match something in the offered.
Let's see. I see what you're saying, yeah. Okay, so you're saying that A1, S3, this one doesn't exist here.
Yeah.
That's correct. That's another error. Absolutely. There's one, there's, as far as I can see, I can see more.
A1 is one and then K1 is one.
Wait, A1,
This row appears in two tables.
where?
The A1 and it is one. And it also appears in the.
These two, right?
Yeah.
Yes, that's also wrong. Okay, anything else? This is fine. Anything wrong with these? No, right? I don't think so. On the other side. This didn't exist over there, so that's definitely wrong. A1 is 3. This one also is wrong. This match over here, this match over there. A1, that's fine. A1, S1. Okay. Yeah, so there's 3 errors over there. 3, right? I think we talked about those 3. Okay. What about this one? This one doesn't cover the entire thing. Okay. Yes.
The schema customer and the table client ID, I don't know if you made an error or if that's on purpose, or they have the same name.
It's about this client thing and this
The name of the table. Client and. The one,
client and this.
yeah, to the beam and the schema above, where you put customer and that's gonna be the surname, right?
You're talking about in the algebra
Yeah.
customer ID? No, it looks like
The name.
the name customer ID and the name. Customer. Oh, it's both customer and client. Okay, yeah. That's right. That's a good catch. That's a mismatch. Okay.
In the email column, it says not. It has to be There is no message, so it's manual.
There is a what?
Now. in the
Okay.
new program. So it cannot be now, since there is no restriction.
Wait, so you're talking about this one, exercise?
Yeah.
To be honest with you guys, like the exercise, maybe it's like allowing no's and stuff, but actually by default, it doesn't matter. The email doesn't really, by default, doesn't matter, actually. I now I get. I think this asterisk sign that saying that allowing no or whatnot. I would let either way go for now, because honestly, like, no one really used that asterisk sign really, like, it's to denote using the algebra. I wouldn't worry about that one so that much anyways. We're only really using the algebra sign right here as an example, because I wanna do an exercise to show you easily like what I'm looking for as a schema. It's not going to, in the exam or anywhere, it's not going to have any question like that. I'm just really, right now, what I want to focus is that I want you guys to understand that the primary keys and then the foreign keys, the referential constraint. Is there any violations of that? Okay, and then primary keys requirement, is there any violations of that? So let's not worry about other syntax here right now, because those are syntax that it's not. I forgot if I tell you guys in person, but if I didn't, but I definitely did that in one of the videos and saying that relational algebra for this class, I will be only using it for this purposes, only just to show a table really quickly as a shortcut. There's other teacher that teaches relational algebra in the database class at length, which I don't find very useful, because out of my 13 years of database or in real life careers, never touch it again. But however, it's easy to do this to show you guys, or you guys can understand immediately a table, what primary keys are, right? And etc. So that's all you really have to know. But that's focusing on more on the constraint parts, the referential constraints. Okay, so forget about the no, well, not no, why is. Okay. All right. So the mismatch of customer and client. Yeah, that's probably a mistake, typo, but it's wrong regardless. Okay, what else?
On the second table,
Yeah, this one, left side? Okay.
yeah, customer ID is a foreign key that refers to client ID.
Yeah.
But number 4 is an
Yes, that doesn't exist, that's also wrong.
And
Yes,
also in the first table, private should be a boolean, so a no is not a valid data.
where?
The first table, the column.
Oh, yeah. Correct,
Should be false.
very right, very much correct, yes.
And also in the statistics tables, there is 2 rows saying this IO. And the third.
Third table, where?
Statistics.
Okay, tell me again what,
The first row and the 4th row,
and then
here.
First-
Duplicate. First and
there's 2 duplicates, it looks like. Well, no, there's 1 duplicate, this with a mismatch here.
Yeah.
Okay. And is there another one? No. So good. So, no. $230. Okay. Did someone say this didn't exist? Okay. What else? Anything else? Pi ID, 1, 2, 3, 4, date, okay, domain. Is there any domain that doesn't ABC, LOL, okay. Test, IO, chow. Okay. In a nutshell, that's it. All right. So I assume that you guys kind of understand these exercises are for the constraint. Now I'm just gonna move on, because we have a lot others to cover. Now, what about this one? Did you guys actually plug that into whichever client that you guys did? Okay, this is just an exercise really that's meant for you guys to see the results, like to actually see what it looks like, right? First of all, these are all the creation. These are all the create statements, right? Which you should already read up on the exercise. I haven't talked in person about, but I think the last recording should have some like very high level, right? Plus that I want you guys to actually have that copy into your client so that you can actually see the table being generated and etc. I mean, what it looks like, right? Okay, so these first create empty tables. First, these two, right? And then as I mentioned last time when we were in person, you want to have the very beginning of the table you would like to have is the one that you have primary keys, and the following ones are the ones that you are referencing it to, right? So that would make more sense when you have these like foreign keys, for example. Now, what about, do we know if the foreign keys can be also in line?
I know it can focus first.
So for the longest time, the foreign keys has to be always on the bottom. But actually, 2 semesters ago, MySQL, I believe someone actually discovered that MySQL, the latest version, does allow the inline now. So, I mean, I still prefer foreign keys to be like all the way at the bottom, but like this, and when you're declarating it, also make sure that when you have foreign keys, there are one time here, and then this is the school that is in here, right? School that's in here, right? And then there's another one here, ID. Okay, that's from up there, right? So there's 2 parentheses, don't forget these. And then don't forget the parentheses with school. When you're doing declarations, be very careful, read it very carefully during the exams. Okay, it's going to be on your exam for sure. Writing up like actual create and then with adding a constraint with foreign keys, it's definitely going to be. And 90% of people have a typo somewhere, and there's a syntax error and there's a run. Okay, it's a closed book, you have to remember. Okay, but it will be all the way at the bottom. It's not going to be an inline one. So I would say that it's up to you guys, like in your actual work, if you want to be in line or not. As long as you're using the latest MySQL, it could be in line when you declare foreign keys. But normally, most of the people didn't know that that's possible. Most of the people, even in like out there in the job. Okay, so then following along with what are these? Have you guys tried these? Also, okay. So what I want, these are important is that to show you that insert statements are not just to do one at a time. You are able to insert multiple rows, right? This is one insert statement into high school, right? As we see. Are you guys familiar with insert? I mean, you should have read up on it, right? So insert into high school, and then you have 5 rows at the same time. This is one execution, right? 5 rows at the same time. So that means that insert statement doesn't need to always be one row at a time. You can insert like multiple rows at a time, right? So let me ask you, all of these together, 1, 2, 3, 4, 5, right? That's say initially high school. This is probably the max amount of columns. That's if I only want to insert like ID name, address, email addresses without the URL. Could I have an insert statement like that? Does it always have to be max 5? Huh?
What was the question?
The question is, if I have an insert into a high school statement, okay? Okay, let's take a look at the high school again. Look at the high school again, okay? So the primary keys is ID. Otherwise, there's no places else that says cannot be null, right? Does it have any not null constraint? No, right? Only the primary keys cannot be null, right? Okay, so insert into high school here. Insert into high school. If I want to say just ID, name, address, and then forget about the URL and email address, is that allowed? It is allowed, okay? Unless any of these was predefined to be not null, when you're doing insert statement, you can leave it null. Understand? That's why I'm trying to get that. So what if I just want to say insert into high school, name, address, URL, email address?
It would be all we need.
Huh?
Wait, what's it? Would it-
If I just have name, address, URL, email
It
address,
cannot be,
and then no ID.
no, ID cannot be null.
Okay, this is a trick questions. It depends. ID cannot be null, absolutely correct, right? It's the primary keys. But it depends on how, if you have your table primary keys auto implemented. So when you do the create table, when you write out create table, right, you can have the primary keys, right, declare, but followed by that, you can also have another constraint called auto increment, meaning that it will just be number. Every time you assign a number, adding one. Okay, if you have that set up, that means that the system will automatically generate a number, primary keys number for you. In this case, we didn't have that. So yes, correct. You cannot not have ID because you didn't set up the system to generate an ID for you, primary keys random number for you, auto increments, right? So in this case, you must have ID, but just, this is the edge case, but just know that you can have using create statement as well as when you're creating a table and when you're setting up hierarchy keys, you can have the database management system such as MySQL or whatever to either randomly assign primary keys the way that you want it to be assigned, like it could be alphanumeric, or it could be numeric, but like starting from, let's say, 8,000, the first one, and then auto generate adding one every time, so that the system is making sure that never will there be any duplicates for you, right? Instead of you inserting it. Okay? Making sure that you guys know that there is a feature for that. Okay? Okay? All right. Now, finally, after we did all these, what is this statement doing?
It's fine, students to school will one, faculty to one, finance one, like, do you mean?
Yeah, but in the way of like explaining without using the word union, like, so what does it end up showing results?
Showing off with the third place.
Huh?
Or it's showing like, the students in the school. Who, as students and faculty of the same school in like the same
Yeah,
structure.
so basically the result is going to show both students and faculty from school one. Right? Because students are from student table. The information of students are from student table. But it does have ID, first name, last name, right? It has that. And faculty, teacher are from faculty table, right? They're initially stored differently, right? But they have shared similar columns, similar characteristics, right? So we want to look at them together from the same school. What we do is using a union, right? What is this doing? Not the date of birth, but as row, student as row. What is this doing? Yeah.
It creates a column row and input student from the team, one student and then from the faculty and puts the value of faculty to the column.
Yes. Anybody hear what he said? So on the fly, it creates a column and then fix the value to be student for students, right? Faculty for all the faculty to kind of differentiate them. Right? It's on the fly only. Let's say after that, like after this query ran, this disappears, right? It gets deleted from the memory, right? This is just on the fly. You can do something like when you do a open quote and closing quote, single quote, right, like this, you're literally giving a fixed string or text value to a column on the fly. On the fly meaning in memory, right? Once this query is closed, once your database is closed, this goes away, right? Similar to when you do join, when you select whatever, when you're reading only, right? Yes? Create, insert, update, these things does stay in the database, right? But when you're doing select, this is just only in memory. Okay, it doesn't affect your original table. Okay, so just so that we are reviewing, so that we're all clear. So remember when we left out last week on this union, can you guys give me a high level of this operations here versus join? Can someone give me a very clear and let everybody hear it? A clear differentiation between union and join.
You know when you want to do like vertical combination and joins for like horizontal.
Yes. Yes, that's a very clear explanation. Anybody wants to add on top of that? There's definitely some that we can add up to. Or explain it a different way. Right, basically he's saying that it's vertical, meaning like it's adding the quantity, the row counts of the result, right, for union. Whereas join is adding more of the column horizontally, right? It doesn't add any to the row, to the quantity of instances, correct? Right? So that's vertical and horizontal, exactly the word that I mentioned a week ago. Now, what else can you say more about this? Or any other one want to try to explain a different way? The other that is slightly on a different angle is when you're doing union, two of the table that you're doing union with are always sharing identical columns. You understand that? Join has not any requirement with that, right? When you're doing join, there's not such a requirement. Union, you're always looking at two of the two tables that are sharing the same column. That's how they can do union, right? That's also a key differences, right? Where join has nothing to do. Join is one single column that needs to share. Yes? You need to find one single shared column in join. Whereas union, all has to share the same, right? You see the differences? So what's your name? What's your name?
Jonah?
Okay, so Jonah explained exactly what happened between union and join, right? But before that, the requirement here is very clear. On here, it shows that all the columns from table A and all the columns in table B has to match for union. For union all. Okay? All right. All right, so these are they're still going to stay on here, but you should really make sure that you are clear on that. Okay, let's see. Any question on the reviews? And exercise? Now, any questions on lecture 4? Box. Okay. All right, so. I think that we covered. As far as progress wise, we covered up to what? Normalization, right? I think we ended, that's where the last material, wasn't it? Like the first normal form. Right, and then there's a video that I added that you guys can watch about the second normal form. That will be beneficial for the mid pitch, but I don't expect more, like that's not a requirement. But that's just pick back from there for now. Okay, so. Okay. Now, let's do an example here. Okay, so. We're giving let's say, we're just giving a table, okay, this could be a spreadsheet or whatever, right? And then from this table, we want to start by moving this table into database, right? We want to eventually make it into database because it's going to start growing and it's going to help us eventually making hopefully something dynamic and then easier for whoever needs these information in the future to use it, right? Or whatever, administrative work or database or a website, etc., right? So what we want to do is we have this, and obviously I would say that I don't know if you guys already noticed, there's a lot of things that we could fix before we make it into it, we'll make it and store into database, right? Because obviously we want to design the database so that it is somewhat better and so there's no redundancy, right? And then it's also conform to different normalizations, right? So, all right, so the first thing first, can someone please tell me, okay? Number one is if I want to eventually move, if I want to design a database to store this information for my colleagues, right? And I want to eventually have the database to be second normal form. Okay, to match the normal form. Now, the first thing before I can get to second normal form is what? It needs to be first normal form at least, right? So do we understand that the higher level of a normal form, it means that every single normal form that comes before it needs to already be fulfilled. It's a requirement for second normal form to have already been first normalized, right? Do we know that? Okay, so we'll start off from the first normal form. All right, can people tell me what are some of the things for first normal form? What are rules for the first normal form?
All named after the unique identity, just like student one, student two, student three. They're perfect.
Okay, we'll come back to that, okay? What else?
It has to be a primary key, so no rows can be the same or duplicates.
No, that's not, there's no, first normal form, there's no primary key requirement. Yet,
I thought you can't have duplicates on the same rows.
that's still not the first requirement yet. That's, you're jumping, it's coming, but first normal form doesn't have that.
Yeah, it can be like a mix of domains.
Mix up domains, yeah.
You can't have a list of value of
Yes.
one cell.
anyone. Okay. Can it has no value? Yes. No value is no problem, yes. The order of it doesn't matter. Does primary key come before non-primary key? Those doesn't matter. Order of column doesn't matter. Okay, those are the trick one is. These two doesn't matter. It does get mentioned always to trick you, but these two doesn't matter, okay? All right, so now, so that, first of all, the first step is first normal form, right? So let's look at this. Non-unique, non-duplicate unique columns. Is there violations of that?
Which one just the status?
Yeah, the first one. Huh?
These three problems.
Yes. Do we see this? Even though they're unique, yes, they're spelled differently, 1, 2, 3. But the problem here includes having to store exactly the same type of value over again using multiple count. That's considered the duplicates, right? For first normal form. Now, if you ask me, what about if I just go ahead and I store these three like the way it is into database, will they run? Will the create table be successful when I do create statement? Yes, it will. Is in another way, it's best practice. It's basically an experience that gather like over time that eventually all these scholars of database eventually figure ahead for you that tells you that if you get first normal form, second normal form, third normal form, that way, you get less of redundancy, you get less of any type of violations or abnormality, right? But it's like best practice, basically. And then the more normalized, the less of redundancy there are. Not necessarily always best for performance. Not necessary. Why? Can someone tell me why? Just if you think about it, why is it not always best performance to be more and deeper normalized?
You have to do all like a join.
Exactly, right? It is true that the more of normalizations perform when you design a database, or when there's a database and then you're trying to refactor it and then normalize it more and more degrees, right? We're talking about 1 and 2, which is basic 2 level, which is what I think the best practice to do in any normal case. Anything further than 3 and 3.4 sometimes is overkill, because you can imagine, just like when you're coding, right? If the class becomes too small, then you got a lot of calls in which a database, the cost is similar to a lot of joins, right? In order to get detailed information from a re-query, you have to join a bunch of times. And remember, when you're learning join, it is expensive. What is expensive? Meaning that it does takes out memories, right? So normally 1 and 2 normalized form is great when you do a practice, when you design for a database. We will, at the end of semester, get to 4 normal form, but we will normally at all your projects stop at 2. And also at your job, it's probably a best practice to get to 2. Okay, 2 is pretty good. On top of that, I would be very doubtful for any of your senior at your, at your work, still remember what 3 and 3.5 or 4 is even like. Really, okay? Right, so that's the first problem is these 3, okay? They're duplicates. Okay, any other of that? Other than that, can we move on from the first one if we fix this one? Okay, what about 2? Mix up domains. Yes.
Under class section, there's like you see saying like the set recently.
Where?
the underclass session, like if they're
Yes. Yes.
it's also like a multiple value transform.
No, it's a URL. Okay. I'm sure that I explained this. What mixed domain is different from mixed type. Mixed data type and mixed domains are two blurry, but they're completely two different things. When normalization say mixed domain means that you're misusing the meaning of that column. Okay, stay with the meaning that you meant to have that column for. It's more than just data type, because if I have data type var 50 for this class session, all these would still run. But for normalization, it's talking about domain, meaning that this is a URL. These are numbers. This is alphanumeric. These are all completely not consistent with this domain. Get it? Be very careful when that happens, okay? Normalization is talking about no mixed domain, not no mixed data type. It's even, the domain part is even more strict. Okay? So yes, these two, okay? What about this class name? There's also a mixed domain, right? Okay, now fast forward, number 3, is there any problem that we see for number 3? Database? What?
Multiple solutions now.
No, where? It would have been a problem, so the no multiple value in one cell would have been a problem if there was something like this. Teaching a system, right? And I have Chris, L, comma, Amy, J. Right? This, you need to go back to your little programming, like, you know, your background, right? Not everybody who learn SQL or data science have computer science or computer engineering background. But you know, when you see someone trying to do this, it's trying to mimic something as an array. Right? Now, this is unacceptable because you're trying to eventually trying to do is that you're making this one cell storing multiple values. Right? This cell itself is no longer just storing one values or unique values anymore. You're trying to actually, you're really trying to honestly put an array in there or data structure in there. Right? So you as a computer science background or computer engineering background, you know that this is a data structure. Like someone purposely is trying to store this to save time and that's a data structure. You know this and you can identify the error, but someone who is not programming background, they don't even know what this means. Number one, and then they won't be able to even tell this is, they need to do a separation. They wouldn't be able to tell that there's two people in here, right? When they get this column or this cell, understand? But anyway, normalizations, this is not allowed for first normal form. Understand? So this is what this multiple value means. Basically, if you think of it like you're using a cell to store the same type of domain, same type of domain value multiple times. And then if you, in other words, you're trying to save data structure in there. Okay? All right, so how do we, let's say supposedly these ones are easy to fix. Okay, these ones are easy to fix. Now, we need to look at these three and this. Right? So, now let's move on to We need to fix that, right, for first normal form. Right, so how do we fix that? So that it will match at least for the first normal form. This issue and these issues. Forget about second normal form, okay, just so that it's valid for first normal form, how do we fix that?
I mean, you could just like leave one student on like the rest of the row, like.
Okay.
First row, you make it into.
You understand what he's saying? What is, can you reiterate what he was saying?
He said that it doesn't give something one comment for the question.
Okay, and then how do we do that? So there's 3 people. And then TA, there's 2 people in here, so how do we do that? How about you? We're thinking about just first normal form. It's right. This is the right way to do it. But exactly how to make that happen? What time is it, by the way? 5%. Huh? 5%. Okay, we have to move fast. Okay. Yeah. So how do we do it?
Bring another table with this for them,
No, I mean,
or
well, how do we fix the table? Yeah, I mean, we don't have to create another table, but like, how do we fix the table so that it's designed to be first normal form? Yeah.
Each student, like every student gives their under the student column,
Yeah.
here like we can add all the students.
Yeah. So it will add more row.
No,
Right.
only one.
No, you have more row.
Yeah.
If you- So 2 will basically, if we're just looking at just fixing this so that it doesn't have duplicates, basically, that's what he was saying, Jonah was saying, is that now. We're just fixing just for this one row, for example, the first row, for example. So that we don't have student 2 and 3 anymore, right? We're just making it to rows. But with just one student column. Right?
Under one column.
Okay, so we fixed in that first column. Okay, now we're fixing that first column. So instead of 1 row and then 3 columns, we're fixing that. So this is fine, but what about the TA part? What about TA? That's still a violation of first, right? What do we do?
We just make more rows.
Yeah. It basically became sort of like a product, right? So TA, and then you just have like. Which is looking at basically like this. Right? Forget about this one for now. Right? As at least fixing the first one. Right? Now. So we successfully at least just dealt with the first normal form, right? Let's say the first normal form is right. Now, obviously, we did remove some of the abnormality, right, using first normal form, but this, would you think that if your database was like this, do you think this is good enough? This is definitely still inefficient, right? Because how many times we're storing just for the TA and students? You're storing A names 2 times or 3, like 2 times, right? Like you're storing Kim 2 times, right? Let's say there's 3 TAs, you're making a lot of loss because you're wasting a lot of hardware in your database, right? So let's move on to second normal form. What does second normal form state? The second normal form states that you should not have partial dependencies. Okay, what is dependency? Another thing about linear algebra that can be used is this. Because of A, therefore B, right? A, therefore B. So B is dependent on A. B is dependent on A, right? So this A in linear algebra means that if there's this logic, it means that A is the key. B is the non-key. Okay, this is another way, another useful way to denote using linear algebra, right? A, therefore B, okay? So that means that B depends on A, correct? So A is what? The keys. B is non-keys. Now, we know that A could be what? It's a primary key. That means that this big A is 1 key, but it could be A1 plus A2, right? Because it could be a composite key. Right? Because primary key can be multiple columns, correct? As 1 key. So it could be plus A1 plus A2. So B. Question so far? This is combo keys, right? The same. It's just key, non-key. So what the second normal form said is that there should not be any partial dependency. What does that mean? If we have a combo keys, which is 2 keys, in this instance, A1 and A2 together, 2 columns as 1 key. Partial dependency means that I need B to be dependent on both A1 and A2 together. It should not be easily identified by just A1, either just A1 or just A2. Understand? Question? Let me repeat what I said. No partial dependency means that your non-dependency, your non-key attribute should not be able to be identified or should not just be dependent on any partial, which is in this case, only either A1 or the only either A2. Okay, that means no partial dependency. Understand? Okay. So let's look back on this. Class, faculty. Okay. All right. So the first thing we have to do now, moving out from the first normal form, right? In this case, is now we have to, because we have to go find the keys now, right? So first of all, what do you think that if we have to make keys, start making keys, in this table, what would have been the keys?
Class ID.
Class ID and what?
Class section.
Section, right? Class and sections, right? Okay. Class and sections. Okay, so does database, if it's class and sections, does it matter with class ID? Does it change based on class ID? Class name, does it change based on class ID? It does. Does it change based on class section? It doesn't. Does it? Does it? Yes or no? It doesn't. That's a classic example of a partial dependency. If you're making class ID and section ID as a combo key, your class name only depends on the class ID. It doesn't change on the section. So that's already a first violation. Okay? Furthermore, A1 plus A2, therefore B. Class ID, class section, these are 0101, 0101. These two together are 1. This is B, right? Is this a B? What is the B? Over there, what is the B? Non-key attributes. So is student a B? It is. Okay, so A, therefore B. A, therefore, is that B? No. They're two different. You see what I'm trying to say? A, therefore B. A, but this is not B anymore. They are two different. Another violation. You see that? Are we good so far? Then we're going to how to solve that. We first have to identify the violation of it. And why are we and then so we understand how to solve that. Do you understand? The two violations I'm showing you from both each directions. The first direction here is non-attribute, this is B, this is correct, they're all databases. But does it care of the section? Like this is not a good example, but does it cares about the sections? No, right? The database, the name of the course followed by the class ID, right? So there's already one violation. The other violation here is that if you have, let's say, if you have a primary keys, then the non-attribute should follow consistently. It should only be Amy and then Amy, right? It should not be Kim again. Or it shouldn't be Kim, or it shouldn't be Rich. All right? So it's actually pretty straightforward. The solutions of this is just taking it out to its own table. And this is where you start splitting the table. Starting with the second normal form. Okay, so Okay. So you have, of course, ID name. Course ID itself and name, not with the section. Okay, separate from the section. And then so student doesn't even get dependent on the courses, right? Student registers to it, so it's not actually supposed to be even in the same table. It validates, obviously validates the second order form, but it should be in a separate table. So there should be a student fee. Okay, and then we'll say that there's a name. Right now, we at least have a name, right? Supposedly it should have additive. Supposedly. Okay? That's fine. Right now, which the requirement, just to break it out, it should have its name. But for good practice, we'll put an ID over there. For student ID. Right? The same thing for TA. Right? I mean, TA could be a student. But like maybe just another column, a trigger saying that they're also a system or something like that, right? Or a flag or whatever. Do you guys agree with that? TAs are normally students anyways, right? Yeah. So we'll just have a TA and then maybe there's a like TA bullying or whatever. And one for 0. Something like that. Okay. So that at least take out the partial dependency. Right? Does that take out the partial dependency? Now let's look at what about the section? Right? So you have the sections in the separate table called register, like or enrollment. Does that make sense? We're clear? So basically you take out the course on its own, right? So name always follow ID, right? There's no more problem with that. The name is always gonna follow course ID A and B. A to B 336 is always gonna be database. 460 is always gonna be data science, right? No matter the sections, correct? Students ID name is always following the ID, right? If he's a tier or not, you know, the ID will tell you, like if that's students, right? Okay, so you use another table to store the sections or to store that this student is enrolled in that class and sections, right? So then in that case, it will be course ID section and student ID together as apartment keys. And is that going to be an issue? No. Right? Because the other columns here will probably be enrollment time or maybe withdrawal or whatever. Those will be non-key attributes that follow these three. Right? So do we have any more primary, do we have any more partial dependency now that we break it out? It doesn't. Okay, so now the key story that we're learning from here is that basically we did all these exercises. The first normal form of the exercise is very much required. The second normal form, you don't always have to think from what I just teach you, like from ground zero, and then you start splitting it all. Basically, the second normal form, you just have to think about, okay, should I have these information taken out? Like these, maybe one or two columns should be its own table. Basically, and then have its own primary keys. So if your logic is thinking that way, basically it will move you towards second normal form. Basically, that was the entire problem because you will identify a lot of partial dependency if everything is stored in one big table, right? So when you start thinking about creating a table, should it be, if there's certain characteristics, certain features, should it go to its own entity, its own table? Right? That's basically before you even start to fix a table. That's how you design it, right? Student goes to its own table, course goes to its own table. Okay? Faculty probably, in this case, actually, that's another example, right? Faculty is probably going to be its own table too, because course doesn't have dependence, it's not dependent for faculty, right? Because there could be different sections. Am I right? Right? Okay. All right, so now another thing that I want you guys to also take a look is that I want to mention here is that the cardinality. The cardinality here. Okay. Supposedly that we don't have. We don't look at this. We don't look at this enrollment here. We're doing a little reverse engineering. There's a lot to learn about secondary normal form, but I'm going to use this example again. So, course and student itself. These two entities in your database, when you design it, what kind of relation should it be, like cardinality wise? Courses and students. It's many to many, right? Why is that?
Course with multiple students and the student can be multiple courses.
Yes, can people hear what he said? Yeah? Okay, let's say what about courses and faculties? Not necessarily. If there's multiple sections. It is one to many, right? Yeah. I mean, assuming each class only have one, each section have only one professor. Okay. Yeah. If it's just course with professor, though, it's still with course. But if there's multiple sections, then that's still many to many, though. Right? Because the section is breakout. It's broken out. Anyways. All right. So let's use the students and faculty, for example. It's a many to many relationship, right? Now, the many to many relationship is a tricky one for second normal form. We already went to like the final result here, so that we already know that we need an enrollment here, right? We went through all that in the beginning so that we get here to find our second normal form database design, right? So if you were to not see this, the final result that I show you, course and students are many to many relationship, right? So what is the cardinality for that looks like for bringing to many relationship? It looks like this, right? Many sign, and this is the many sign. If it's one to many, it will look like what? One to many. Something like that, right? If it's one to one, it will be this. This shouldn't be this shouldn't be unfamiliar or foreign to you. Do we agree? At least cardinality wise, how to denote those cardinality? Yes? Okay, so for second normal form, can this actually happen? For second normal form. Can you actually have a second normal form database, data modeling, seeing two table, and then there's a many to many relationship like this? That doesn't validate second normal form.
Oh, right, you need like an intermediate table, I don't know. It's called.
Did everybody get? Does anybody disagree with me? There's a many to many relationship here, and then, but I want to have a second normal form, like I asked you to draw a design database that is at least second normalized. To the second form, second normalized form. And you find out there's a course and a student here, and then we agree that it's many to many relationship. Can we just leave it as that? Yes or no? He says no. Anybody disagree? Can we just leave it with many to many? So he's correct. And the answer was here. It was literally here. So we kind of did the reverse engineering of I'm telling you that we did all these to see that this was required. To basically see that your first normal form, to get to second normal form, you're going to need this. You're going to need this. But however, sometimes you don't get to have these tables to start off with first normal form. You're going to have to start from scratch, let's say, to design the lab. And then you come to face a normal situation where there's two entities, and they have a relationship between each other, and they're many to many. And you're now thinking, can I just do this? The answer will be no. Why? Because we literally just did that exercise. We literally just did it. This is just kind of like a disguising. And we get to the answer before we are even asking the question, can we do this? Okay? Now, what Jonah had mentioned is that, no, you cannot have this many to many relationship. And now you're saying, okay, so then how do we denote the relationship to it? When you have these two similar situations, we have two entities that have many to many relationship. What you need to do is you must have a transitive table. Transitive table, also known as weak entity or joint entity. And the word entity can be switched to tables, right? Weak table, transitive table, or joint table between them. And this is what that table is. This is that table. This table in Roman is that table. Remember we talked back in the day where when we have ER diagram. When we have ER diagram, remember we're drawing actor actions and we're drawing the character, the three types of shape, right? Circle, relationship, right? Which is the diamond, and then you have the square one with entity. Remember that? And remember when we're in second or third class, when we learned about primary keys and foreign keys, we learned that that is one way to replace the relationship, right? To join one table, to join the relationship between two tables, right? Today, we're learning another one, slightly more sophisticated. This was meant this table over here is meant to store relationship between two entities that has many to many relationships. When it comes to second normal form. When the precondition is, when I ask, when you're trying to develop a data modeling for second normalized form, right? Because this was fine for first normal form. This is okay when we just want first normalized, right? We do see the problem with it. Do you guys see the problem with the redundancy developed, right? Was first normalized. It took out a lot of not good stuff, incorrect stuff. But we did see the redundancy here. But if you're moving on to second normal form, there's no many-to-many relationship. The relationship is denoted when there's a many-to-many relationship between two tables. You need to put another transitive table in here. Now, let's finish up with cardinality. Cardinality. So we have a register or enrollment table here. There's my chart, okay. Or we call it enrollment table over here. What time is it? Okay, right? Register or enrollment, aka enrollment table, right? It's a weak. It's actually not a weak entity, but normally we call these tables in between to store relationship between many to many. We call it joint transitive or junction. Okay, these forms are all names for this type of table. Only that when you cannot use the word weak when you put primary keys into it. Let's say if there's no primary keys in these tables, you can still use the word weak. I don't know why they come up with this word weak. I think the word weak entity just probably back in the day when people just think that this table was created just for the purpose of joining two tables, so it's a weak entity, right? And then you cannot refer it as a weak entity once it has its own primary keys. I mean, this is childish, but honestly, but that's all these are literally talking about the same type of table. Okay, just make sure that when you're referring to this type of table, once it has its own primary keys, don't call it weak entity. You can still say join, transitive, or junction table, all these still valid. Got it? Just a small little bonus. Now let's finish the cardinality. Course and student. Do we have any cardinality drawing here? Do we draw anything between this and this?
No, right, so it goes through the register.
Yeah, okay, someone complete this exercise. Do you know? We're gonna finish the relationship with cardinality. So who wants to start? The first cardinality class. Between what table to what table? Forest and what?
What's that mean?
Enrollment table, you mean?
Yeah.
Okay, cardinality is between two tables. Okay, all right. This and this table. Okay, what kind of relationship?
Let's see the one to many.
One to many. Where's one? Where's many?
So it could be course one.
Forest is one.
Yeah, it could be many rooms.
Okay, and what about over here?
It could be many of them.
Many, how do I draw many? It's a fourth. It's a fourth. Did everybody hear what he just said? This is the course table. This is the junction table. Enrollment. The relationship between that is one to many. Okay, who want to try? Next one, it's not done yet. What about you over there? What's the next relationship? Is there any more relationship here missing? Right now? Want to pass? Do you have an answer? No. You don't? Okay. Who else want to try? That can't be it. Can it be it?
Your students.
Wait, I know, I want other people to answer. Do you have answers?
Many to one or going to standard.
So your enrollment is many to one? Like that?
Yeah.
Yes. Are we done? Do we have more relationship? Once again, this is course ID section. Student ID. Are we missing any more cardinalities? In relationship? Any more missing? Okay, that's it. Okay, we don't have anything between this. Nothing. We're using this to come to join the two table. We're using this. Therefore, the join, transitive, junction, the relation has been passed. Because why? Because there is the primary keys linked to over here. Not here. There's no primary key over here. Well, there is a relationship. No, nothing, right? And there's that primary keys that's in here forming. Right? They don't have direct link. It's all linked in here. It's been joined over here. Any question? Okay. Finally, a shortcut for your own purposes, so to speeded this up. When it comes to cardinalities, and you have a joint table like this, or many-to-many relationship, and then when you want to meet the requirement, which is the second normal form, on the exam or like homework, project, whatever, right? The trick here is to think parent and child. The parent has the DNA that passed on to the child table. Right? So you only need from you either one dad or one mom. Something like that. Right? And you can have multiple children. But you only need single parent, right? And then multiple children. Always think of it that way. And then it's the parent's DNA that pass on to child, right? Not child the other way around. So the DNA I'm referring to, guess what I'm referring to? The what? In this case, I'm using a metaphor, so what I'm referring to? I'm referring to the primary keys, guys. The parent table has DNA, which is the ID here, primary key, that's been passed down here to the child table, which is the foreign key, right? Parent, child, always one to many, always, always. If you remember this as a shortcut, you will never get it wrong. The primary keys are the DNA of the parents, right? It passes on to the child, which has the foreign keys, inherited from the parents, basically, right? The child can be 2, 3, 4 child of one parent. So multiple child, one single parent. See that? Dad, mom, right? Multiple children. That way you will never forget, it's always one to many. The transit table is always the many. Got it? That's the shortcut. Never wrong. If you use this metaphors as a DNA from the parents, And then parent has multiple child, whatever. Okay? Children. All right, what time is it? So we actually still have 24 minutes. I want to do another exercise so that we can like fortify this and then we'll leave the last 30 minutes. Is that okay? So we can get this over with. The data modeling for second neural form over with this stuff, with this course. Okay. Right, so this next exercise is going to be very important because what we did just now today is we moved from 0 now to second normal form. That is from drawing from a spreadsheet or a table that your colleague created, and then we're trying to make it into database, right? And we're trying to make it as normalized as much as second normalized form, right? That's what we did here today, right? From a non-normalized random table from anybody who accountant, whatever of your colleagues, giving it to you, and then you're trying to design it to store in the database so you can make an app, whatever, or you can do a data science work, whatever. You're putting that, and then you're trying to make it into second. That's what we did. Now, let's flip things. But we have to do this exercise quick. Okay. Okay. We're going to create a database for this. Netflix. Okay? We're going to create a database for this. Now, normally when you come to a database, and I already did provide this as sort of like a step forward. Normally when you want to build an app, or if you're into interview or whatever, or you're thinking about an app, you're inventing an app, or you're building and developing something from scratch, right? You think about the idea first, what is the app is for, what it is. Then you start thinking about how, right? Some of the things that it does. Right? You think about, okay, I want to build something that I can let my users stream movies or TV content or whatever, right? Then you start thinking about, okay, I'm building this app, what can it do? Right? Now, these are the things that I listed just to save you guys some time. I want to build an app, let's say, pretend that Netflix doesn't exist. I want to build an app that can do these things. Okay? And I want our exercise to be designing a database to store for this app. Okay, now. Question? Anybody don't understand the assignment here? Okay. Everybody from this side? Okay, what are actors here? 5 media by a certain language. Tell me a table. Who want to start here? Table.
You like media table?
Media table. What are some of the huh? Wait, let's put ID first. Always.
The ID name, then language,
Okay. All right. Let's move on, second one. Oh, gosh. Second one, what do we need in our database? If we want to build a function with this dynamic functions,
you can have the site.
where would that be? Okay,
You need a views table for like. Tracking like who's buying. The things like these on here. ID. User.
okay. Something like that, okay. What else do you need?
User table.
No, are we done with the second requirement use case?
Ratings.
Rankings?
Ratings.
Top 10, you mean? Okay, the rankings, we haven't gotten there yet, the ranking is derived out, right? You don't need to store that, right? Because it changes. You use sorting and using aggregations to get that derived out. You don't need to store. You understand what I'm trying to say? Yeah, it's calculated. What else? We're missing region, right? Where do we store region? USA. We're not storing USA anyway. Where should we store that? Huh? And then why is what? That's fine, just store it out there, let's just talk about it.
It's not even from the answer.
Huh?
There's only.
In the user, okay, so user and then like what we just saw that.
ID, name, password,
No, but I'm talking about specific that thing in USA. Okay. Okay. All right, let's move on, third one. Do we have places to store that already or?
I think there is that.
Okay. All right, so next one, someone else want to try? Do we have places to store that? Do we know the assignment here? Like, I want to make sure it's not just 2-3 of us that understand the assignment. You're a developer or you're an entrepreneur. You come up with a brilliant idea, you come up with Netflix. Right? And you're thinking about these are the use cases you want to initially build as a VIP. Use cases, functions for your users. Now, you're not going to have no database to create this app, right? And so we've gone through the first 3 now. On the fourth one, if I want to find actors, find a movie or find a show by actor or actress, do we have places to find that? Huh? In media? In media and then where? Language is here for it. We're on the fourth one, find by actor actress. Yeah. Like that under media. Inside media? What is the relationship between the actor and media? Do you think? We can put an actor, right? But what do you think will be a problem with it? Yes.
Then the actors can be.
Right? We're talking about second normal form, right? So this thing is probably not a good idea, right? But we do need actor actress. Right? So what do we do? Yes. Okay. Now, next one.
The history table with email and password.
Okay. Okay. Show me on the shows. Do we have ways to store that? This one is a advanced question, slightly more advanced, you have to think about it. Unfinished shows. Yes. What will you solve it?
I think we can put it in manual. Because we can put like the user ID, the media ID, and then put like the checklist is watching one. It's video ID.
Unfinished shows. What is unfinished? Is that the same as watched? Question is unfinished.
Maybe we can change the watch to completed, where they completed watching the full.
Yes, you're getting there, but how? How do we? I guess the question is, in order to know if it's finished or watched or completed, how do we know that? We will need to know about something, yeah? The duration first, right? So we need to, in order to know we watched the whole thing, then what is the whole thing? How long is the whole thing? Right? So where would the duration be? View is how much I watched. Yeah? Immediate. Are people following? When I ask unfinished shows, what is unfinished shows?
So like watch time is not.
Yes, your watch time is less than its length. Or watch a portion of it. But if you don't know the length of it, how do you know? How would you be able to calculate? In your database, I mean, like there's the tricky parts here that you guys are thinking about. That top 10. No top 10 is you have to find out is by how many views and then you're ranking them, right? But you will need to know the views, which we have. But ranking them later on, we can use database to do the calculations, right? Or your programming language can use to do a calculation. That's fine. We can derive. That's called derived value. You don't need to store it, right? Because you can get it after you're calculating it, right? If you're storing the views, then you are getting it after you're calculating it. But if I'm saying unfinished shows, if you don't know the length, how does the system tell you that this show has been watched fully? You can't. You need to store. That's what the database is here. Why is it dynamic? Because you have the length of the show, you're storing how much you watch, next time they will know. If you don't have a database, how would you know? But your database needs to be storing the length. And then in the view, it needs to be storing how much it watched from and to. Right? Are we following? Okay. Now, let's start making this into an actual database. We have 10 more minutes. All right? So, okay? What are these? What are my joins? No, this is not your, this is data modeling. ERD is the square diagonals. This is actually, I know on the many of you, even there's professors that's disagreeing with me, But at least for my class. When I talk about ERD, it is the one with the diamond shape, circle shape, and we passed that. We'll continue mentioning that, but I'm not going to ask you to draw that in your exam again, or you're not going to put that in your project. We're going to move on and we're going to start drawing this UML standard diagram or data modeling diagram or schema design. Okay, and especially when we want to draw 2 NF with the cardinality and everything, this is the only way to draw that, not the ER diagram that we drew before. Okay, we're like we're elevated from there. Okay, so we're drawing a data modeling diagram, and these are tables. Is there anybody who's lost right now and speak now or hold your peace? Because this is very, very important. This is the highest portion of any single exercise on your exam. Grades wise, score wise, that you know how to draw this. And it's going to be second normal. We're designing from scratch a second normalized database. And we're just now we went through all of those. First out to list out all of the possible tables and schemas, right? And now we're putting it into a diagram. We also did that earlier with the table. So we're doing 2 types of different exercises to get, second normalized form exercise. Okay? That's what we're doing now. All right, so now we have media and users. Okay, media and users. Views. Where do I put the views? Where do I put the views? Actually, you know what? Another word. I'll give you a hint. Where do I put between? How do I get a relationship between user and media? What are possible relationships? User and media. Views, possibly, yes. Just to think outside about views is one, and what else? Could be one. What else? Watches. Well, I mean, that's kind of in views now. But think about social media. Media as a user? No. Media in this case is like TV shows, right? So what other relationship can be between user and media? Likes, rates, right? I don't have to necessarily watch it. I can save it, or even right. I can like it, right? I mean, when you open Netflix, don't tell me you never open a Netflix. You can like a show, you can follow a show, you can do many things other than watching, right? You can read about it, right? Sure. So, all right. So then, media and user, what relationships would there be between them?
1 to many.
User and media. We just know that the possible relationship, possible actions are views, likes, and all that stuff, right? Okay, so user reviewing media. What are in this relationship? What is the cardinality? It's many to many, right? User can watch many shows. A show can only be watched by one user? No. Can be watched by many users, right? So view / watch is many to many. So why do I do this? What's this? What's this view and watch table? What do we call it? We just did that over there. The weak entity. Why? Why do we have a weak entity, guys? Come on. So we have 5 minutes where we have to linger longer and longer.
And that draws connection between two.
Many, because user and media are many to many relationship, right? We have a weak entity. So now what's the cardinality?
Maybe one to many, one to many.
Okay, one to many, where's one to, where's many?
One user, many, users.
Okay, what about here?
One medium, media.
Get it? The first one here. Okay, if I want to do a like. Well, actually, no, I want to do a following a show. Well, I mean, that's the same thing. Follow, likes, whatever, for ranking a show. What do I do? Follow, like, or ranking a show. What would I do?
Being more weekend news,
Between,
media users.
okay? Do we get that? Actually, I wouldn't do that right here. Just example, I'll link it somewhere or something, but you get that, right? So now, I want to do that by following actor. So someone will volunteer and draw that. Want to do that? Because I want to find my favorite actors, right? Earlier on, you know, I want to find by actors and actresses, right? Maybe I want to find. So far, we are able to find, you know, find me language, media, blah, blah, top 10 USA. Sure, you know, media, and there's within views. And media, right? Media has a region over there. Actually, it says user. The country said user. So that's still fine. We'll be able to find that media, user, and view, right? That will give us the top 10 shows in USA, right? Do you understand this? How do we find this?
Like views.
Yes, right? So by views, why is it that now with the views, why is it that we can find it? The USA, where would we get from the views?
But we would like join and aggregate the user views and media table.
Okay, in the views, because we have primary keys from users, right? The countries, it's a user, right? So if we join them in the where clause that the country says USA, that's how we get USA, right? And then all those rows returned. We can later on we will learn about grouping, which is aggregation. Basically, later on we'll learn about other calculations. But at least the information will be these two joined together. Actually, 3 of them, because you need to get the media name, right? The views of what shows. Right? So you'll get the name of the shows here, you'll get the countries here, and you'll get how many people are viewing in the USA of these shows. Get it? Okay, so if I want to follow a user, come on, let's quickly get this over with. I want to move on now. How do we get that?
User follows an actor.
Yeah,
Like you make another candidate.
okay, so find by the actor actually saying you don't actually need to follow, but I'm just saying like, I want to make an example of like, actually, I want to look at shows that with the actors I followed, right? With the actors that I follow. So between media and actors, what relationship would it be?
Many to many.
It will be many to many, right? So what do I do? I'll have a weekend see, let's say play or act. Right? Okay, quickly. Finish your cardinality. Where's one?
Yeah.
Okay, what about here?
One after.
Okay. All right, use or follow factors. What relationship is it?
Many.
One to many. Wait, one to many?
Like user one.
Okay, and after followed by only one user? Okay. Okay? Are we clear? Are we clear on the basics of coming up with your own map? List out all the use cases functions. Think about what to store, what schema you first need, and fulfill their relationship in a second normal form. Yes? Then you may ask them, okay. I don't have anywhere that has any one-to-many relationship. The second normal form has no one-to-many relationship. No, that's not true. In this case, we're just practicing all the many-to-many. But one-to-many, like natural one-to-many, for example, it could be this. So it could be this. For the time's sake, I don't want you guys to think about it, but I'm just gonna do it. Right? For example, media and media type. Okay? Supposedly what I meant by media type is either it's a movie or a TV or a documentary or like a game. Okay? All right, so can the media be can the media have multiple can it, how what is one media can have how many media type? One. A media type can be multiple media. So what kind of relationship would it be? One to many. So where's one? Where's many?
One media.
One in media.
Many media.
Where's the primary key?
In media.
Media has its own primary key, but to store the media type, who will have the DNA?
Media, the type.
The type will have the DNA. Get it? Now finish the one to many relationship. Where's one? Where's many?
One media, many. Yeah.
No. Yeah.
One media type, one many media.
Okay. The parent always has the single. The child always has many. Okay. All right. I'm gonna go wash my hands. So who wants to go first? You guys can decide, and then go set up your own. On the. Using your own laptop.
There's network.
Oh, yeah, yeah. People to me. Who does?
Our got it from.
Like,